Okay, hello everybody. Happy Friday. As I talked about in the introduction video, Friday is going to be when I'm going to post a video like this where I'll kind of talk about some of the questions that you guys had on the discussion board, clarify stuff that um, you wanted clarified, you know, be able to have more two-way communication with you. All right, so um, this week, not a lot of material, mostly you guys posting your introductions, which I really enjoyed reading. I'll hopefully be able to tailor the course to be more focused on stuff that you guys are interested in. But there were a few questions, two about the kind of structure of the class, and then another about statistical software, so we'll talk about that. The first thing was someone asked about the exams, the midterm and the final. So here I have the midterm I gave last fall. So basically the format is there's a bunch of multiple choice questions. So that's, I mean, you obviously won't know what I'm talking about here because you haven't taken the course yet, but, multiple choice, and then um, also some short answer questions. So you have to, express what this mathematical equation means using plain English, or talk about what errors I've made, maybe do a little bit of calculation, stuff like that. So that's going to be the general format of the exams, is just multiple choice and short answer. And I said in the introduction video, one change I'm making is that I'm going to make the exams open book, open notes. So the questions might be a little harder, but you'll have the ability to have access to your notes. And as long as you, and you could even, go online and try to find a paper. The only requirement there is that you cite your sources. All right, so that's the exams. The other one, someone had a question about due dates. In the syllabus, it just says that, a problem set is due this week. So I think the most fair thing would just be to say, it's due Saturday night, 11:59 of that week. So just as long as you get it to me that week of class, you can give it to me as early or as late as you'd like. Okay, so that's exams, that's due dates, and then we had a couple of people talking about statistical packages, more specifically Stata versus R. So I previously said that if you that I would recommend that you use Stata. Stata's probably more commonly used for econometrics, though I say R is kind of up and coming. But the main difference between them is that R is a programming language, like Python or C++ or whatever. While Stata's a piece of software, like, PowerPoint or Excel or something. So to kind of show you the differences between the two, I'm going to kind of show you the steps you would take to do the same thing in R and Stata. So this is R Studio, which is kind of like a wrapper for R. So let's get some data in here, and this is going to be this pretty similar in both. This process is going to be pretty similar in both packages. Okay, so I have this data. We're just looking at people, I've got 10,000 people. I've got their height and their weight in this data set. So let's import it. We'll call it weight. Everything else here looks good, so we'll click import. Okay, and then R is going to import that into memory. To make sure that we have it, we can type in this little console, we can type weight, and it lists all of our data so we know it's there. Okay, and what we want to do is we want to run a basic linear regression, basically find the line of best fit, if you remember from Stat 250, of height on weight. Okay, and so to do that in R, we basically have to create a model. So we'll give it a name. We'll just say model equals. Okay, and we want this to be a linear model, so we say LM, and then enclose that in quotation marks. Okay, and then we say we want to predict height. We put tilde, say that we're doing it as a function of weight. And then we also need to tell R which data we want to use, because one thing that R can do that Stata has a little bit more trouble with is having multiple data sets. So we want to say data equals our weight data. Okay, we hit enter. Enter that code. All right. And so we can see that it's stored it over here, but we still actually don't know what that model is. So to do that, we need to do summary, and then in parentheses, we want to get our model. Okay, and here it's giving us everything. So there's the intercept and the coefficient. You don't have to know what this is yet. We'll talk about it in future weeks. All right, another thing we could say is, what if we want a scatter plot? We can say plot model. And so there it is. There it's giving us all of the different plots associated. That's residuals versus fitted. How can I get, maybe if I run it again, I can get a scatter plot. I guess it's just giving you, oh, okay. So yeah, there are all of the stuff. There's all the plots associated. Again, you don't have to know what this is, but that's generally how R works, is that you're going to be, typing stuff into this command line, making sure you get the, syntax right, making sure you put tildes where tildes and equal signs and specify what data set you're going to use. Okay, so that's R. Now for Stata, again, first we need to get our data into it. So we'll go file, import. Our data is in CSV format. So again, we'll go browse. Oh, here it is right here. Okay. And again, both Stata and R are pretty good at importing stuff. Okay, so let's just hit OK. Okay, and so here, the thing with Stata is that it's a lot more graphical. So we can do everything from this command line down here, but we can also just kind of click through menus like we're using any other piece of software. So if we want to see what our data looks like, we can just click here, and it brings up this window, which kind of looks like an Excel spreadsheet. And so here it's showing us every single observation and our data. All right, and if we want to run our regression, so the first thing we could do is we could use a command line just like with R, but the syntax is a lot simpler. So rather than having to do model equals lm tilde, we can just do reg for regress, height, weight. And it also just gives us the output right away because Stata knows that that's what we want. But even if we don't want to learn commands, even easier, we can go to statistics, up here, linear models, linear regression. We can say our dependent variable is height, our independent variable is weight, hit OK, and it'll give us the same output. So we don't even have to learn what the command is. We can just use this graphical interface here. Same thing with scatter plots. We can do graphics, two-way, create. We want a scatter plot. Y variable is height, X variable is weight, accept, OK. And it's going to kind of crunch for a little bit because we've got thousands of observations. And there's our scatter plot. So that's the basic difference between R and Stata. So R is, again, you're going to be doing pretty much everything through this command line. You have to know the syntax of how certain formulas work and stuff like that. Stata is a lot more user-friendly, but it's also more limited. Again, for what we're doing in this class, you're not going to need to import new libraries and stuff in R. Or use multiple data sets at the same time. So that's why I recommend Stata, because it's easier. It's not it doesn't require you to learn an entire programming language. You can use it just like you would a piece of software. And even when we get more complicated, we say we want to use robust standard errors, we can just say use robust standard errors in the graphical interface, and it'll do it for us. But if you already know R, it's fine to use. So, if you're starting from scratch on both R and Stata, Stata is easier to learn. But if you already know R, I wouldn't go through the effort of learning how Stata is unique. I would just use R. The other thing is that R is free. Now, as a GMU student, you have access to Stata. But if you, in the future want to use a software that's more open source, and that's just your preference, then go with R. So I hope that kind of illuminates more the difference between um, statistical packages used for econometrics. Some people said that they use stuff like JUMP or which I think is based on SAS, or even all the way back to like StatCrunch in Stat 250. I would say Stata is more similar to those than R is. Okay. So I think that was pretty much all the questions. Again, not much material this week, just kind of getting to know the course, getting to know each other, kind of giving an outline about what econometrics is and why it's awesome. So I hope you guys have a great weekend, and I will talk to you. Well, you'll watch me on Monday. We'll get into some causal questions in the social sciences and start having some fun. So nice talking to you. Please let me know if you have any other questions. Peace.